Hi, Viper Chemistry students. Hey, once again, let's try to do some problem solving with mole ratio and how to predict how many moles would be produced from knowing a set of moles of one thing or another. But anyway, I we ran across a problem in our this mole ratio problems problem solving activity number 2, and this was problem number 8. So I thought this was a really interesting problem. I love chemistry for this reason because it forces us to do some critical thinking and do some problem solving. Nothing could be better than that. So let's take a look then. Kind of do some adjustments here. Up here on the board, then in that problem number 8, it shows a formula here, which is iron hydroxide. Okay, so there's that. And asking us what kind of reaction would this be? Asks us to predict the products, and then it asks us to do a mole ratio problem, knowing how many moles of the reactant. This is the reactant here, and then it tells us how many moles of water. So that gives us a clue as to one of the products here. So that's cool. Anyway, there's a lot there. We can break down, do some critical thinking here. Now, what we want to do then is let's assume that water is going to be produced and also iron oxide. So iron oxide will be produced and water. Now, how do we know what the formula is for iron oxide? We know that it's going to be iron oxide and water. We know what the formula of water is. Now, so the thing to do here is you got to figure, okay, this is iron 3 hydroxide. Hydroxide is a -1 polyatomic ion, and there's 3 of those. So that must mean this is iron 3. So if this is iron 3, this would be a 3+ charge. So we had 2 of those. Oxygen is always a -2. So there's got to be 3 of those. Okay, so whenever we're working with iron 3, then if it combines with oxygen, it's going to be this formula here. Okay, and then water. Now, we need to balance this equation. And so to do that, what we'll probably try to do here is let's go with a 3 in front of the water. We could put a 2 here and a 3 over here. Now I'm using a 2 here because this was iron 2 here, or there's 2 irons there. So if we try that, then that's going to give us a total of 6 hydrogens. And if we put a 3 here, will allow us to have 3 oxygens, which matches up here, and 6 hydrogens. Okay, so that is a balanced equation. So the ratio becomes 2 to 1 to 3. Okay, so that looks like a nicely balanced equation. So we'll keep going here. Now, the type of reaction here is a decomposition. Because it's starting with a reactant and it's breaking down into some products. So that's a decomposition reaction. All right, let's do our mole problem. So we know that we have 0.79 moles of the reactant, which is iron hydroxide. And now we need a conversion factor so that we can get to moles of water. So we know that there's 3 moles of water for every 2 moles of the iron hydroxide. Now, when we do the math, we've got it set up where we can cancel our units here. This would cancel and this would cancel here. And that would leave us with water. And when we do the math, it turns out to be, let's see here, 1.19 is what I have here, 1.19 moles of water. Okay, and so that then is the solution to the problem. So this whole process that we're using right here is called dimensional analysis, and it's setting it up so that you end up with the right unit. Okay, so we needed moles of water, and we're going to end up with moles of water by virtue of how we set up our conversion factor. And we're